strings. Okay, so in previous session we discussed about the basic string functions and the pattern matching, how can we insert new string, all those things we discussed. So today we'll move on to the KMP algorithm. Then we'll discuss about the sparse matrix also. Okay, so this is North, Moore and Pratt algorithm. This is shortly called as KMP algorithm. Okay, so here for the KMP algorithm, the efficiency will lies in this failure function. Okay, so first when the pattern mismatch will happen, that failure value we have to find it out. Okay, so you may get question like how to calculate the failure values. We may give you the pattern. Okay, the pattern string will give, and we will ask you to find out the failure values. Failure function will ask you to apply over that. Okay, so for example, if you have the values like a b c a b c a c a b, if this is a string, how will you find out the failure value? Okay, so this pattern is mentioned here, and here we are giving the failure values. Okay, so if here this row F, if you see, that is failure value calculator. So for the first character we will write the failure value as -1, then A and B will compare, there is a mismatch, so -1 will write, then A and C will compare. Okay, mismatch is a -1 will write, when A and A we compare, there is a mismatch, so the third character is matched with this 0th character, so 0 we have to write, then there is a match. Okay, so J value will increment by 1, so B. Okay, so B and B when we compare, okay, so this fourth character is matching with the next one, so this sequence A B sequence is matching with this A B, so here we'll write 1, and the next one C. Okay, so this A B C is matching with this A B C sequence, so here it will come 2. Okay, so fifth character is matching, 0 1 2 characters are matching with the 3 4 5th character, then next one is A. Okay, so A B C A. Okay, so here the third character is matching with 6th character, so what you have to write, 3 we will write. Okay, so now, okay, A B C A, B is here, but here if you see A B C A, C is there is a mismatch, so what we have to put here, -1, because it is mismatching, that sequence is not happening, so -1 we have to put. Okay, so the next one is again from the beginning we have to do the matching. Okay, so here A. Okay, so here with the first character is this matching, so 0 we will put here. Okay, so the next one is here after A, B is there, so this 0 and the first character is matching with 8th and 9th character. Okay, so it will be 1 here, so the 0 here the failure values, if you see, -1 -1 -1 0 1 2 3 -1, again this 8th and 9th character is matching with the 0th and first location character. Okay, so in this way failure values you have to find out. Okay, so now we'll see the KMP algorithm for the pattern matching as well as how to find out the failure value. So failure value, if you see, n value, it is whatever the length of the string we have taken. Initially the failure value we have taken it as -1. Okay, so from 1 to nth value what we are going to do, initially whatever there in failure of j -1 here, if you see. Okay, so now j value will be 1, so failure of j -1, it is -1, right? So that value we are taking here. So I equal to failure of j minus 1 we are taking. So pattern of j and pattern of I plus 1 both are same. Okay, so here if you see pattern of j is b, pattern of I plus 1 is I is initially it is minus 1. Okay, so here minus 1 plus 1 0. Okay, so here 0. So pattern of I plus 1 is okay, pattern of 0, and pattern of j is presently 1. When we are comparing it, they are not same. So what we will do, we will here we will be putting it as the values, both the values we are checking here. Okay, first failure value how we are finding out, we'll see. And if I value is greater than or equal to 0, I equal to failure of I. So here what is I value initially we have taken? It is failure of j minus 1. Now j value is 1. Okay, so failure of 1 minus 1 is 0. So failure of 0 value what we have, minus 1. Okay, so now that here if you see minus 1 is there. Okay, so the same value we will copy to failure of j here. Now j value we will increment. Okay, so here if both of them are equal, pattern of j, so how long we will keep on doing this until there is a mismatch. Okay, so what we will do, we will be putting minus 1 as the value. Okay, whatever there in failure of I, that value will copy. Okay, and if there is a match, what we have to do, I value we have to increment, that we will copy to failure of j. So that's what we have done here. Okay, so we are comparing the failure of 0 with here the pattern of 0 we compare with pattern of 3. Okay, pattern of j you are going to compare with pattern of I plus 1. Okay, so now it will be 3. If both of them are equal, what we have to do, we have to put here, we have to put failure of j equal to I plus 1. So I value is presently minus 1. Minus 1 plus 1 it is 0. Okay, so that we have to copy here. Otherwise in failure of j what we need to put, we have to put minus 1. Okay, so this is the way how failure function we will use. Okay, so here how the pattern match function will work with the usage of failure values we will see. Okay, so the pattern match function will accept two arguments. For the first one is string, second one is pattern. Okay, and I and j value we are initializing to 0. Okay, so now the length of string is whatever the string length we will copy it, and length of pattern is how many characters are in pattern, that we will copy till we reach the end of the string, until we reach the end of the pattern we will be incrementing I and j value. If the string of I is equal to pattern of j, we are going to increment. Okay, and if j value is 0 also, what we have to do here, we will be incrementing I value to fetch the string character. That's why we are doing this one. Okay, otherwise whatever the failure of j minus 1, okay, so j value if it is 1, failure of j minus 1, it is minus 1 here. Okay, so that value we will add with 1 and we'll do it. Okay, so once if the pattern values are matched with string value, what we are going to do, we will find out from which character from in the string the pattern is matched, that we will return. Okay, so this is the way how KMP algorithm will work. Okay, so I want you to prepare for this failure function finding out also. Okay, so now Okay, so this is sparse matrix. Okay, so when will we use sparse matrix? So if you have more number of zeros in your matrix, in that case, instead of simply storing the zero values, no more memory space will be wasted. So we can start using the sparse matrix concept. Okay, so here if you see, there is a 6 by 6 matrix. Okay, so here 6 rows are there and 6 columns are there. The contents are 15 0 0, 22 0, minus 15 0, 11 3, 0 0 0. Then in the row 3 minus 6 is there, row 3 completely 0, in row 4 91 is there, in row 5 28 is there. Okay, so many zeros are there, right? 3 7 12, and here 12 plus 6 18 plus 5 23 plus 5, so 28 zeros are there. So out of 32 values, 26 values are 0. Okay, it's waste of memory. So if 1 byte is if 2 bytes, if 4 bytes are used for storing the integer data, so 4 into 25 values, 25 zero values we are storing here. Those many bytes will be wasted. Okay, 100 bytes will be wasted. So think about the scientific application where lakhs and lakhs of data will be storing. Okay, so many zero values will be there, means it's waste of memory space. Okay, so even if you want to fetch a particular data, so much you have to search. Okay, so what we can do, so if zeros are there, then we can eliminate the zeros. Only the non-zero values we can store in the sparse matrix. Okay, so here if you see, in the sparse matrix 3 columns we will use. Okay, column 1 2 and 3, and here how many non-zero values are there? So non-zero values are 1 2 3 4 5 6 7 and 8. 8 non-zero values are there. Okay, so only those non-zero values can be stored. Here if you see, another matrix is there, 5 rows and 3 columns are there. In that if you see, all elements are there, all are non-zero elements, so no memory space. But here if you see in the B example, there are so many zero elements are there. Okay, so now let's see like how can we create the sparse matrix abstract data type. Okay, so here we will use the triplets. Okay, row value, column value and non-zero element we are going to store. Okay, and here in the sparse matrix, okay, in the first row we'll mention how many non-zero values are there. Then after that we'll start storing the row number and column number and the non-zero element we are going to store. So what are all the different functions which you can write for the sparse matrix? You can create the sparse matrix. Okay, so how many rows and columns you need, that you have to mention. If memory space is available, then the sparse matrix will be created with the row size and column size. So we will use array of structure here. Okay, and the second function which you can possibly use is transpose function. Okay, so the row values become column values will become row values. Okay, so that we can, that function also you can write. And the next one is adding two values. Okay, adding two sparse matrices. Okay, so we will check for the row value and column value, we'll find out and we will add them and we'll store. And the next one is multiplication, multiplying two values, two sparse matrices. Okay, so for that what we will do, in the destination sparse matrix, a of I of k we will multiply with b of k of j and we will store it. Okay, it's a normal matrix multiplication how we do in the same way. Okay, so now let's see the sparse matrix generation. Okay, So in the sparse matrix, in the first row, okay, what is the matrix size? Okay, how many rows are there, then how many columns are there, then after that you have to mention how many non-zero values are there. So in the example what we have seen previously, no, 6 by 6 matrix, and in that this is a matrix, okay, the B part. So 6 by 6 matrix and 8 non-zero values are there, so that we will store. Okay, so here here if you see the 0th row 0th column 15, 0th row 3rd column 22, 0th row 5th column minus 15, 0th row 1st column 11, 0th row 2nd column 3, 2nd row 3rd column minus 6. Okay, so all those values, only non-zero values, we will store here. Okay, so this is a way how it will be stored. Okay. Okay, so now we are going to create sparse matrix. Okay, so for sparse matrix generation, what is the maximum row and what is the maximum column we have to give. Okay, so here there will be 3 columns, so column, row value and non-zero value. So for each and every term these 3 fields will be stored. Okay, so we are going to create the terms here. Okay, A is a sparse matrix. How many terms you want to create, you have to create here. Okay, and when you want to find out transpose of a matrix, okay, so in ith row jth column, if we have stored a non-zero value, then in the jth row ith column that value will be stored here. Okay, so in 0th row 0th column, if 15 is stored, and in 0th row 0th column only in the transpose matrix also the value will be there. In the 0th row 3rd column 22 is there, means in the 3rd row 0th column the values will be stored. In the same way in 0th row 5th column minus 15 is stored, means in the 5th row 0th column minus 15 will be stored. In that way it will be maintained. Okay, so how can we generalize? In ith row jth column if non-zero value is there, and then in the jth row ith, okay, after transposing the non-zero value will be stored. Okay, so let's see the simple transpose matrix. Okay, so we will pass the actual matrix and where we want to capture the transpose. So A is the input and B is the transpose. Okay, so here we will pass I and J induction variables also we need, and what is the current B also. Okay, so whatever the necessary variables we will create. So A of 0 dot value is nothing but the total number of non-zero elements. Okay, so now in the transpose matrix, in the actual matrix how many columns are there, so many rows will be there in the B matrix. How many rows are there, so many columns will be there in the B matrix, and n is the total number of non-zero elements. If n is greater than 0, okay, then only it means that we have non-zero elements. Okay, so current B it is initially we'll make it 1, then after that 1 by 1 non-zero value will access and will store. Okay, so here if A of 0 dot column how many there, so that will become row value for the transpose matrix. Okay, so for I equals 0 and I less than A of 0 dot column, because we are going to put it in the B transpose matrix. Okay, and for J equal to 1, J less than or equal to N. Okay, so here this is used to access the non-zero elements. Okay, so if here we will be accessing A of J dot column if it is equal to I. Okay, if it is there in the ith column, then what we are going to do, we are going to store it in the ith row. Okay, so the current P variable will help us to access the present non-zero element. Okay, so here b of current b dot row equal to, so the column value we are making it to row value we are making to column value, and what j value, if you see here, it we are incrementing it till we access all the non-zero elements. Okay, and then after accessing it, current p value we are incrementing. So this is the way how the sparse matrix we will use. Okay, so here to find out the if you want to optimize it, what we can do, we can make use of the row terms and the starting position. So what we have seen here, it's a very simple method. Another one is optimize method. Okay, so here this is a sparse matrix. Okay, so in each and every row, how many non-zero values are there, that we are going to calculate. So in 0th row, if you see here, here if you see the column, okay, so in 0th column there are 2 elements. So in 0th row, so many elements will be there. In first column, which are all the elements there, they will be there in the first row. In second column, how many are there, they will be there in the second row. In the third column, how many are there, they will be there in the third row. Okay, so now here in the 0th row, okay, 2 elements, so we are referring the column here, because in the transpose matrix they will become row. In the first row, 1 value, the second row 2 values, in the third row 2 values, the fourth row no values, in the fifth row 1 value. Okay, so in the sparse matrix, okay, in the 0th row we will have the number of rows, number of columns, and the non-zero elements. Okay, so the first row will start from 1. Okay, then in the second row also first row will be there, of first row elements will be there. Then after that 1 plus 2, if you add, we'll get 3 here. So the first row here, it will start from the third location of the sparse matrix. So 3 plus 1, 4. So from the fourth location we will get we will be getting the value here, that is a position in the sparse matrix to store the second row. 4 plus 2, 6 means the third row will be started from there. 6 plus 2, 8 means from that row the values will be stored here. 0 plus 8 means from the 8th row the values will be stored. So this is the way how will we use the row terms and the starting position. So now let's see how the fast transpose work along with this row terms and starting position. So first you have to pass the actual sparse matrix, then here sparse matrix B will be used here. Okay, so row terms and the starting position array we are using I and j index values, and total number of columns, total number of non-zero values we are capturing. Okay, so the number of columns will be copied to rows, and number of rows will become columns in the transpose matrix, and the number of non-zero elements are, they will remain same. So if number of terms greater than 0, so then what we will do, if I is 0 till the number of columns, we have to repeat it, because for the transpose matrix they will become the row values. Okay, then we are initially saying all the row terms element to 0. After that, okay, we are copying the row terms values, row term of a of I dot column we are incrementing by 1. So initially the starting position of 0, okay, initially it will be 1, because in the 0th location in the transpose matrix we will be having the total number of rows, total number of columns for the matrix, and the non-zero element. Okay, so here what we will do, we will start copying the values. Okay, so here how I told you, starting position, how will you calculate? 1 plus 2 is 3. Here row terms plus starting position, present starting position will add. Okay, so the same logic is used here. Starting position of I is equal to starting position of I minus 1 plus row terms of I minus 1. Okay, and then here how many number of terms are there, that we are going to copy. Okay, So starting position of a of I dot column in that location, okay, so that we will copy to j, then we will increment starting position, then column value will copy to row value will copy to column, and the non-zero value will copy as it is. Okay, so this is the way how we'll be performing the sparse matrix. Okay, so with that the first unit will be over.